Hello guys, welcome once more to the online class. I'm Tutor Dami and we shall be looking at Jamb Physics 2019 question number 6 to number 10. You know, our job here is to simplify these questions and make it practical so that it can be something that you can relate with. Anybody can do physics, I always say that. And anybody, once it is well explained, then you can always go about it. So let's check out. Don't forget to also like this page if you really enjoyed this video, if it was helpful to you, so that we can get to reach you from time to time with more content that will help you in your journey. So let's check out number 6 now. Number 6 question said a dam is able to hold a large quantity of water because its wall is what? Now, dams are like, they are stoppers, like something that you place in the middle of a river in order to stop the water or to control the flow of water. Let me use a picture to explain that. A dam is a barrier that stops or restricts the flow of water. So, you know, rivers, some rivers, mighty waters have dams. So dams help to control the flow of the water and also to generate electricity. So now let's talk about dam. Now, how is a dam built? Like, I have a picture there of a dam. You know, the dam was not too happy with the water. The dam is there to stop the flow of the water. And the water was not too happy with the dam in my picture. So the water was coming towards the dam and the dam was there to stop it. But how is it built? You can see, does it have a larger upper side or a larger lower side? The wider the bottom, the stronger the structure. So if you have a tiny bottom and you have a big structure on top, that structure is going to crash. Because for you to have a structure that will stop water, water has terrible pressure. So if you are going to stop a river, you must build a structure that has a lower base. That's a very practical question. Okay? And let's check out the option thick at the top. Will it be thick at the top? If it's thick at the top, the water will crash it at the base. Then if it is thick at the middle, the water will crash it also, because middle thickness is even a higher problem. Then thick at the bottom is just simply the answer. This is just basic one question, primary one question. So it has to be thick at the bottom. The base has to be thick for it to stand firm, right? Stand firm. So the answer is thick at the base. And option D, unfortunately, is not there. It's not in the past question. So it's thick at the bottom. Now let's check out number 7. A body of mass M moving through a circle of radius R with a uniform velocity V experiences a centripetal force F. The work done by the centripetal force on it is what? Now, this is just asking that what's the work done by, you know, whenever you hear the word circle, that tells you that it is a circular motion question. Now, centripetal force has its own formula, but whenever something is moving in a circle, like if you have a fan and then light goes off, your fan keep rolling, right, by centripetal force. Centripetal force is the force that keeps things moving in a circle. Now, whenever something is moving in a circle, what work is done when centripetal force is at work? What I mean is that if light is taking, right, and your fan is rolling, what is the work being done by the fan? Okay, what is the work being done by a centripetal force? And you'll be shocked. The answer to that question is centripetal force is equals to 0 work. That means when your fan is rolling, when there's no light, the fan is not working. The fan is soon going to stop, because the fan is just rolling, trying to complete some. It is falling. So no work is done. And the reason is, but why? Number one reason is displacement is 0. The fan is not covering any displacement or any distance. You know, actually it's covering the distance in circle, but it's not being displaced in a direction. So that means 0 displacement. There is no friction. That means there is nothing stopping the fan. Then number 3, acceleration is 0, and that's the most important force. The most important reason. The fan is not accelerating. The fan is not running faster. It is just moving. It's not really going faster. It's not increasing in velocity. It's not increasing in velocity. So the fan is just moving around and getting slower and slower. So no work is done. The fan is not working. Okay. Then the last one is centripetal force is perpendicular to velocity, but that's not actually a strong reason. But the stronger reason is that acceleration of the fan is 0, and also displacement of the fan is 0. You know, work is force times distance or force times displacement. But in this case, the fan is not moving. It's like if I have a wall and I'm pushing the wall. Now in science, if you have a wall and you are pushing the wall, like you are pushing, move. If the wall is not moving, in science, it is said that you are not working. So because for you to say that you are walking, there must be a force which you are pushing. Yes, there's a force, but there must also be a distance. If the wall is not moving and you are pushing the wall, but the wall is not moving and no distance is covered, then in science it is said that you are not walking. So in the case of the fan, it is not accelerating and it is not displacing. Then the fan which is rolling with centripetal force is not working. So the answer to that question is the work done by centripetal force is simply 0. 0 work is done. Okay, that's statement number 7. Now let's check out number 8. Don't forget that. Number 8, a block is acted upon by 2 auxiliary force as illustrated in the diagram. You can see a 10 Newton force, a 1 Newton force. The acceleration at 1.5 meter per second square, the acceleration please is at 1.5 meter per second square. Calculate the mass of the block. Now, to find mass, when you are given acceleration and you are given the force, it's just to use the force formula. Don't forget that force itself is mass times acceleration. We are told to find mass. That's easy peasy. So I'll just first of all, I will have to find the net force. You know, we have 2 forces acting on that body. You have to first of all find the net force. So the net force is the first force minus the second force. That's 10 Newton minus 1 Newton. So the net force or the main force is 9 Newton. Okay. So now recall that force is mass times acceleration, right? So therefore, my force is 9, my acceleration is 1.5 in the question. So just make mass the subject. So mass is therefore 9 divided by 1.5, and then my answer is going to be mass is equals to 6 kilograms. Don't forget, it all came from the formula force equals mass times acceleration. Make mass the subject, then divide the force by the acceleration after doing the net force or finding the net force of the forces. Okay, so that's all I did now. It all came from the formula force equals mass times acceleration, and that is very simple and very straightforward. So that is number 8. Now let's check out number 9 now. Number 9, of course, my answer is A, 6 kilograms. Let's check out number 9. Which of the following quantities are dimensionally independent? Dimensionally independent. Now let's see. What does that word mean? Let me explain that. Now that's very easy. Dimensionally independent means it has no unit. It has no unit. Now all of them have unit. Now don't mix up formula with unit. All of them are formulas, but not all of them have units. Okay, all of them are formula. What I'm saying is that all of them are formula, but not all of them have units. Okay, now which one is dimensionally independent? Now that means the one that has no units. Okay, we have dielectric constant, which is defined as the permittivity of the material divided by the permittivity of vacuum or air. So that's the formula for dielectric constant. That means it is just, you know, the word dielectric is that which is placed between two capacitors. In between 2 capacitors, you have a dielectric, which is an insulator which does not allow the flow of charge between them. So dielectric is given by the formula permittivity of material divided by permittivity of air, but it has no unit. So even if you calculate the dielectric, there will be no unit. It is not, you can say 5.6 is the answer for the dielectric, but you will say, even if you say 5.6, you can't say 5.6 what? Is it 5.6 meter or 5.6 Newton? There is no unit, so it is dimensionally independent. Okay, because it has no unit. Okay, it only has a formula, but it has no unit for its answer. Next one, we have momentum. Momentum is mass times velocity, and the unit of momentum is kilogram meter per second. Okay, kilogram meter per second means that momentum has a unit. So if you have your momentum answer as 5, you will put kilogram meter per second, and that means it has a unit. So it is dimensionally dependent. It is not independent. The next one is efficiency. Efficiency is mechanical advantage over velocity ratio times 100. I'll come again. Mechanical advantage over velocity ratio times 100. It has no unit. So if your efficiency is 50, you just write 50%. It has no unit. You can't say 50% Newton or 50% meter. It has no unit. So it is efficiencies is dimensionally independent. Then we have refractive index, which is the sign of incidence divided by the sign of refraction. This one too has your no unit. So if your refractive index is 1.5, it is just 1.5. 1.5 nothing. 1.5 nothing. It is just 1.5. It has no unit. It has nothing you can call with the answer. So when I say unit, I mean what I can call when I say the answer, what I must say next after the answer, and that is a unit. But these guys, they all have no unit. Dielectric has no unit. Efficiency has no unit. Refractive index has no unit. Except momentum has unit. So the ones that are dimensionally independent are dielectric constant, efficiency, and refractive index. They have no units, and that means that they are dimensionally independent. And that gives me the answer as option 1, 3, and 4. Option 1, 3, and 4. And that is my answer for question number 9. And let's check out number 10. A body is projected from an initial velocity as the 0 to the horizontal, at theta to the horizontal. If R max or maximum resistance is the maximum range of the projectile, what does the refraction initial velocity square over maximum range represent? What does this formula represent when you are dealing with range? That's just the summary of the question. What does this formula represent when you are talking about range? Okay, so let's check it out now. Now, this formula can only be gotten from the range. You know, when we're talking about range, we are talking about projectile formula. Okay, now when a body is projected, you know, it spoke about theta. When something is moving through theta angle, it is talking about projectile motion. And these are the formula for projectile motion. You know, we have time. The total time is 2u sine theta over g. And the maximum height is u squared sine theta square over 2g. And the range is u squared sine 2 theta over g. These are the three formulas to know in projectile. Whenever a body is moving, when I say projectile, I mean when something is thrown. Okay, when you have a question that is talking about something being thrown at angle theta, that is a typical example of projectile question. Okay, now whenever you have that kind of question, they can only ask you 3 different things on projectile. And these 3 things are the 3 different formulas I showed you now. They can only ask you for time, from total time, or maximum height, or range. Now this question is asking about range, but it's asking you to turn around the formula of range and show me, if you have this kind of formula, u square over r max. Okay, what will be the value that will give you u square over r max? Okay, now that formula, so that's zeroes down on the range formula. R equals u square sine 2 theta over g. Now if I invert that formula, if I turn it upside down, or if I make g the subject, I'll be having g equals u square sine 2 theta over g. Now in this case, and that will give me my r under and my u square on top. So that means that the answer to that question is simply g equals u square sine 2 theta over g. Of course, in this case, the theta was left out. So we have g equals u square over r. And that means that g is the only one that can produce u square over r, where my r is below. And that gives me my answer as g. So the value for that will give me u square over r below is acceleration due to gravity, which is g. Okay, so it's not vertical distance, it's not horizontal distance, it's not the acceleration of the body, it is just acceleration due to gravity, which is g. And I got it from the range formula, okay, by turning the range formula upside down. And that brings us to the end of this section. Now don't forget, if you really enjoyed this video, to like the video. We have more to share with you to help you with in your journey as you go to learning physics. Don't you want to have a formula book like I have? I always add a formula book that helps me to remember the key formulas in each section. I recommend it for you. It will help you. So let's go from now. See you guys. We will see you later. Until we see you next time, take care of yourself. Bye for now.